thank you to Novium for supporting BBS. We are almost certainly the first technological civilization on Earth. But what if we're not? No, we are. But how sure are we, really? A favourite way to estimate the abundance of life in the universe is the famous Drake equation, which figures that the number of intelligent alien civilizations in our own galaxy who might overlap with us can be estimated by multiplying a chain of factors, basically summarised as the number of habitable planets times the probability of a planet forming life, then technological life, then factoring in how long that civilization survives. We know that there are billions of habitable planets in our galaxy, but the other parameters are still extremely difficult to guess, and that's because we only have one example of the formation of life and civilization to go off, and we have 0 examples of a technological species going extinct, although we're on track to get at least one of those. If we detect just one more instance of life or technology out there, we'll immediately be able to upgrade our guess at the probability of any given planet reaching that stage of development. But you know what would increase the probability even more? If we saw that it happens twice on the same planet. There's an extremely loose piece of evidence, not even evidence, maybe just a teaser that life may have started independently twice on Earth. There's this zircon crystal found in the west of Australia that contains a tiny speck of carbon that looks like it was filtered through a living metabolism. It has a characteristic higher proportion of carbon-12 versus carbon-13 that plants breathe out. That speck of biogenic carbon was probably perfectly sealed in a zircon crystal, probably from around 4.1 billion years ago, dating it to before Earth's crust was probably reliquefied by massive asteroid bombardment that should have extinguished all life. And that's a lot of probablys, but this is crazy given that the next earliest fossils in Australia and also in Greenland date to between 3.5 to 3.8 billion years ago, and that's after Earth re-solidified following its pounding. If so, then abiogenesis, life arising from non-life, would have had to have happened again, and that'd mean that life really does start very quickly given the right conditions. We'd have to update our Drake equation estimate of the probability of life forming given a suitable planet. But all of this is extremely speculative, and one reason is that it's really hard to verify the origin of life because these fossils are extremely scarce. Greenland and that little bit of Western Australia are the only fragments of land still left on the surface from that time. The entirety of the rest of the crust has been subducted, pulled back into the Earth's mantle by tectonic activity, not once but many times. The crust is recycled roughly every 500 million years, meaning much of the early fossil record has been deleted, which makes it extraordinarily difficult to track the early rise of life. But if the geological record is so crappy, then in 500 million years, Earth's new inhabitants will have precious little evidence that we ever existed. So could we even know that we are the first technological civilization on Earth? And if we're not the first, that would have huge implications for our Drake equation, forcing us to update both the probabilities of technological civilizations arising from life and also our lifespan estimates for those civilizations. I know this sounds like some lizard Illuminati rubbish, but one effort to properly address an out-there proposal like this is in a paper by NASA climatologist Gavin Schmidt and physicist and astronomer Adam Frank from a few years ago. They proposed the Silurian hypothesis, which asks whether pre-human industrial civilizations might have existed. The name is an old-school Doctor Who reference. I'll leave you to Google it and to see what we're actually looking for. Let me be quite serious for a moment. I don't think such a civilization existed. Schmidt and Frank don't think that such a civilization existed. The burden of proof of such a claim is massive and massively on the claimant, and currently there is no real evidence. The actual purpose of this video and of the Silurian hypothesis is to frame a very clear scientific question around a very speculative idea. So let's do just that. Broadly, that question would be, could a non-human industrial civilization have existed before us given our current lack of evidence of such? And expanding on that, if so, how long ago would it have had to have existed in order to be completely erased by now? And what traces of such might still exist that we could now look for. But first, to start thinking about what evidence a past civilization may have left behind, let's think about what our civilization will look like in the far future. Our species has been around for 300-ish thousand years, but has only had a major impact for the past 10-ish thousand years of the Anthropocene era. By definition, this is named as the era of our major impact. And that impact has massively accelerated in the 300-ish years post-industrial revolution. When you look at the world now, you might think that our constructions are the most telling signs of our presence once we're gone. But that won't be the case for long. The pyramids may have lasted millennia, but they won't last millions of years. All of our great cities will erode to dust, be covered up or washed away, or end up as deserts. Then ocean floors, then deep sedimentary layers, then mountains, then deserts again. Much will also be pulled beneath shifting tectonic plates, subducted. It'll be reforged into new rock in the mantle, and its geological memory almost completely wiped before it re-emerges, if it ever does. So will any signs of these works be apparent in the far future? The recycling of the crust means that anything older than 500 million years is pretty much gone. But we do find plenty of fossilized dinosaur bones that are hundreds of millions of years old. So surely we'd find the remnants of a civilization that's only millions of years old. But that is not necessarily the case, because of the potential limited extent of the civilization both spatially and temporally. We have of course obtained samples of Earth's surface from many millions of years ago. Some of those areas are still exposed, but most we reach by digging or drilling. But here's the thing. We have accessed only a tiny fraction of a percent of the original Earth's surface from before the Quaternary period, 2.6 million years ago. And modern urban land coverage is less than 1% of Earth's surface today. So if a civilization just like us existed a few million years ago, it's extremely unlikely that we today would have stumbled on their physical remnants. That includes cities and artifacts, but also fossils. The fossilization rate is so low that we've only discovered a small fraction of the species that ever existed. Remember that the dinosaurs roamed the Earth from around 240 to 65 million years ago. They've been gone for a third of the time that they were around. And across those 180 million years, we have just a handful of specimens. By comparison, our 10,000 years of civilization is barely a blip in the fossil record. Our industrial era, not even a blip. We can find T-Rexes, but we can't find T-Rexes from a particular few centuries. I'll elaborate on the extent of the Anthropocene blip. Our best way to trace geological time is in sedimentary rock. This is rock that originally formed from the precipitation of dead ocean things onto the ocean floor, building up over millions of years. From sedimentary rock that's been exposed, or from deep cores drilled into the ocean floors, we can analyze these layers to track changes in ocean chemistry, temperature, and biological content from these layers, which in turn reflect those same properties on a global scale. The entire Anthropocene will be represented by a layer only several centimeters thick in kilometers of sedimentary layers, with the industrial age a proportionally tiny fraction of that, perhaps millimeters at best. Although a far future civilization probably wouldn't find our bones or artifacts, they might find and recognize this wafer-thin layer in the geological record. As our structures and cities grew, so did our broader footprint. Anthropocene is the word for the geological era dominated by human activity. It's not quite textbook yet, but probably will be soon. Geological eras are periods of time reflected by distinct changes in the geological record. The Anthropocene certainly qualifies. In fact, the geological marker currently being laid down in new sedimentary layers due to our activities bears an eerie resemblance to some of the transitions in the geological record from millions of years ago. So, to assess whether any of those previous events might be connected to industrial activity, let's take a look at the specifics of how we are going to confuse future geologists and paleontologists with the crap that we're sprinkling over the surface of the Earth, that are already seen in some of the newly laid sedimentary layers. First, There are the more direct chemical and isotopic imbalances due to us making a bunch of weird stuff. Industrial pollutants like heavy metals and chemicals such as CFCs and their long-lived byproducts, consumer waste like rare earth elements and plastics, nitrogenous fertilizers and even steroids from large-scale farming, radioactive isotopes deposited globally from nuclear weapons testing that will last tens of millions of years. Then there's the effect of habitat destruction and species extinction, which won't be so much a distinct layer in the geological record as a sudden drop in the markers of biodiversity. But our main geological impact, of course, is climate change. Remember that speck of biogenic carbon in the Aussie crystal? Well, this is more than a speck. Over the Industrial Revolution, around 500 billion tonnes of carbon that's rich in C12 isotope has been pumped into the air. This is increasing the ratio of C12 to C13 in the atmosphere, which is then reflected in the soil and oceans, and ultimately in the sedimentary layers currently being built. The rise in temperature associated with this new atmospheric carbon will influence the geological record in a number of ways. Increased rainfall and rising sea levels increase erosion even further. Warmer oceans give up more of their dissolved CO2, increasing their acidity. This and the temperature change itself alters the fauna that can live in those oceans and ultimately the layer on the ocean floor. There are many other known and unknown effects beyond these. So from all of this, it sounds like it'll be easy for a future civilization to see where we scrawled our "we was here" in the geological record. And if so, we should be able to find a prior one. Except that so many of these signals can be duplicated by natural phenomena. We'll come back to those natural explanations, but first, let's see if there are any interesting past geological markers that look anything like the one that we are currently forging. Let's go hunting for pre-human technological civilizations. Our geological record contains several candidate weird layers that also represent massive environmental shifts. Some we understand well, like the Cretaceous-Paleogene boundary, which is connected to the dinosaur-hating asteroid hitting the Earth. But some still don't have broadly accepted explanations. And here we get to the Silurian hypothesis, which asks if any of these as yet unexplained abrupt shifts in the geological record could have been due to an industrial civilization. Schmidt and Frank focus on two broad types, which have a lot of overlap. We have the hypothermals, largely in the Eocene from 56 to 34 million years ago. These are characterized by rapid increases in global temperatures and are often accompanied by significant shifts in carbon isotope ratios. The latter suggests that the temperature shifts are due to rapid injection of CO2 from burning of some organic fuel. We are triggering a hypothermal now, but could some of the past hypothermals also have been triggered by something like us? Not impossible, but stand by for the debunkings. Then we have ocean anoxic events, a few of which are found in the earlier Cretaceous and Jurassic periods. These are characterized by a rapid drop in the oxygenation of the oceans, accompanied by a great dying of ocean life. We're seeing the beginning of a potential OAE right now. And as in our case, the ancient OAEs are often accompanied by shifts in the CO2 isotropic ratios, and so could also have been triggered by climate change. Going back further, there have been several abrupt shifts since around 500 million years ago involving combinations of the signals that I've already described. And the further back we go, the harder it is to pin down the definite cause. So there's more and more room for our flights of fancy about dinosaur empires. The biggest challenge to assessing the Silurian hypothesis is that natural climate shifts can duplicate so many of the current anthropogenic signals, from the change in temperature and the carbon situation to the different types of minerals being deposited on the ocean floor due to changes in ocean life. And there are many potential natural causes for climate change. For example, the periodic shifts in Earth's orbit characterized by the Milankovitch cycles, which we covered once upon a time, and which are correlated with past climate shifts. And if a signal is not caused by the climate change itself, then it might share a cause with that climate change. For example, spikes in heavy metals or rare earth elements can come from the manufacturing of technology or be produced by volcanic eruptions which spew vast quantities of minerals and metals into the atmosphere and oceans. Radioactive isotopes could be due to a nuclear program or due to a nearby supernova explosion. Layers of soot and particulates in sediment could indicate combustion processes from an ancient industry or come from widespread wildfires or an asteroid impact. These can send soot and dust into the upper atmosphere, eventually settling around the globe. And more importantly, can trigger a shift in the climate if enough CO2 is released. There's good evidence that the Paleocene-Eocene thermal maximum, the first and greatest hypothermal of the Eocene, was caused by a giant magma zone intruding in a giant fossil fuel bed. And these sorts of catastrophes and the associated climate change can also trigger the type of mass extinction that we expect to accompany our own geological bookend. That said, there are some things that we are doing to our own geological layer that would be hard to explain naturally. Some of the long-lived synthetic chemicals really have no known natural source, like some of these industrial fluorides. There are things like the chirality of molecules, the left or right-handedness of their symmetry that is strongly one-way in nature but random in our industrial production. I should also point out that past sudden climate shifts appear to have been significantly less sudden than our own. So if we found a shift that had occurred on a timescale of centuries rather than tens of thousands of years, that might be an indication. Speaking of timescales, we have a bit of a paradox here. A civilization which perished due to climate change would leave such a narrow record that it might be invisible. On the other hand, a much longer-lived and so presumably environmentally sustainable advanced civilization might produce minimal ecological disruption over millennia and so would be similarly almost invisible. In any case, distinguishing between these artificial and natural scenarios requires extremely careful analysis of the context, distribution, and composition of these markers and their association with each other, all while piecing together clues that could span geological epochs. So, have we detected the signs of industry in ancient geological transitions? No, we have not. But our search has also been quite limited. And this is the true value of the Silurian hypothesis, as Schmidt and Frank themselves emphasize. It's not to propose pre-human industrial civilizations as a likely explanation for past geological events. Rather, it's to refine our understanding of what to look for if we wanted to find evidence of such. And although it seems extraordinarily unlikely, the implications of discovering such a pre-human civilization would be impossible to overstate, both for our sense of our own place on this planet, for our understanding of the likely abundance of civilizations in the universe, and it can even guide us to looking for past life, even past civilizations on other worlds, starting with Mars. But most importantly, discovering an extinct people who reach the same or higher level of advancement as ourselves would give us a stunning new perspective on our own future and a profound reminder of our fragility. Perhaps enough of a reminder to allow us to avoid that hypothetical predecessor's fate and avoid becoming just another local geological blip that had once dreamed of exploring all of space-time. Thank you to Novium for supporting PBS. Inspired by space, the Novium HoverPen 2.0 Interstellar Edition is a high-end pen designed to defy gravity at a 23.5 degree angle to be a subtle reminder of our home planet's axial tilt. Whether writing physics formulae or taking notes on your favourite show, the HoverPen is available in Starlight Silver, Mars Magma, and Neptune Blue. But if you choose Space Black, you can also own a HoverPen that contains a piece of the Meonion-Aluster meteorite, which landed in northern Scandinavia more than 1 million years ago. Each meteorite fragment is accompanied by a stainless steel certificate certifying its origin. Novium offers worldwide shipping, and gift options are available. There's a link in the description to learn more.